Okay, so this is video 2, vectors and scalars. So when we look at a vector, okay, we'll be representing something like a force, velocity, and so on. Okay, so anything that's a vector you can represent with an arrow. Okay, so in this case we've got a head of an arrow, we've got a tail, and that shows direction. Okay. Now the other thing it can show is the length of it could be the size. So greater the length of the arrow, the greater the size of the force or velocity or so on. Okay. Now you could have two vectors. Let's say we had two 50 Newton vectors. So let's say we had a box, okay, and you're pulling it with one vector of 50 newtons. So you're pulling it with a rope, something like that, with a force of 50 newtons. And then you also have another person with another rope with 50 newtons. What is the total force and direction? So the total force is going to be 100 newtons to the right, okay, as denoted by the direction of the arrow. So we could do some more. We could do, well, what happens if we have 50 newtons backwards and 50 newtons forwards? Well, you actually get 0 newtons. What about 70 newtons forward plus 30 newtons backwards? Then you get 40 newtons to the right. Or you could get 100 newtons to the left plus 10 newtons to the right, and that will give you 90 newtons to the left. So you could actually measure this. This could be 9 centimeters, this could be 1 centimeter, and that could be 10 centimeters, and essentially you got 10 plus negative 1 makes 9 centimeters. Now something that is going to be a bit more important is creating angled vectors. Okay, so whenever we might have an object and there'll be a force heading off in this direction. Okay, if there's that case, then that's okay, it's pretty straightforward. Let's go to size, 50 newtons, something like that. Okay, if I now add in another force, let's say it could be on the same object, and it is going like that. So I've got two forces. This one, let's say, is 20 newtons. Now, what happens here is we need to add these two things together. It was simple before, it was just adding the two numbers together, but in this case they're at an angle. So there's an actual angle here. Okay, so we actually need to adjust it accordingly. So, how do we add them? Well, what you do is you grab the tail of one and add it to the head of the other one. Like that. And then you then get a final resultant vector that we denote with two arrows going from the first tail to the last head. And you always add head to tail. Now it doesn't actually matter what order you put it in. I could actually go and grab this one. Oops. See if I can grab it. That one there. Put it there. Then grab this one. Oh, which grabs everything. That's a hassle. And put it there, and I would actually get the same resultant vector that I had before. Now what would the actual value of it be? Well, you grab your ruler and you measure it. Okay, so we'll actually do this by measuring things. So let's say this is the proper way of doing things. So let's say I had a tree, funny looking tree, and we have some ropes going out of it, and one was 80 newtons and one was 60 newtons, and they had an angle of 40 degrees between them. Now what you would do, you would actually then draw this thing properly. Okay, so you'll draw so one arrow like that, there we go, and that would be the 80, and then you'll draw the 60, a bit shorter. Now what you should do is when you do this, you actually measure this one as being some sort of scale. In this case we'll say our scale, which you should write, the scale is going to be 1 centimetre will be 10 newtons. So does that make sense? So every centimetre is 10 newtons. So in this case here, the length of this side is going to be 6 centimetres, and you'll draw this with a ruler, and then using a protractor, with this one being at 40 degrees, we'll make this one 8 centimetres. Now what you do, grabbing your ruler, you then measure, you draw a vector at the start there, that is this one being moved to there. So this one is going to be 6 centimetres, and it's got to be the same angle, 40 degrees, than it had before. Okay, and then what do? Well, hopefully you know that you must now put a resultant vector from the first tail to the final head. There's our resultant. Now how do you find the answer? You grab your ruler, you measure that, and let's say in this case it was, I'm just guessing here, let's say it was 12 centimetres. So 12 centimetres will be equal to 120 newtons. And then you grab your protractor and measure the angle at, let's say, 20 degrees. Okay, so you actually measure it with a ruler and a protractor.